all the students and the viewers, the new efforts that has taken by Praveen Shukla ji to celebrate this National Technology Day is something that is going to come up as a great feast to all of you. And to start with, one of the best technology demonstration by all our Indian engineers and technocrats, at the same time the scientific community, which is planned, and I'm pretty sure in days to come, most likely by the end of 2021, or maybe somewhere in the first or second quarter of 22, we are going to witness one of the important mission which is planned by India, and by which we are going to help the not only the national but the international community to understand the importance of the solar energy, importance of the radiations that are being radiated by the sun, and what are all the important aspect of understanding the solar radiation is going to be one of the important message that is going to come out of the mission Aditya. So I felt that today we should talk on the indigenous technology demonstration which has been planned by the Indian Space Research Organization in collaboration with the various institutes from India. And let me tell you, this is one of the great mission that we are going to witness. So I will not take much time, and as I know there are illuminaries who are planned to give you the great amount of information on this occasion of Technology Day, I will be short and brief so that all of you just get a feel of what the India is going to be and where we are leading in the days to come. As we know that India is a country which has been known for its traditional values, traditional knowledge, and India has always been forefront of demonstrating such technologies and science from the ancient to modern period. So as far as the modern time is concerned, we look forward that India leads as an Vishwaguru in a 21st century. And some of these missions are giving us a great idea about how the technology demonstration is going to lead for the entire humanity. So Mission Aditya, which has been planned to be launched in 21st, like later in the year, or if because of the pandemic situation, there is likely chances that it may be postponed for a few more months, but certainly in a 2022, we are going to have a great mission called a Mission Aditya. Now, let me tell you that why do we really need a mission like an Aditya when there are huge amount of investments are there in the field of space sciences from across the globe. जैसे आप समझ सकते हैं कि पूरे विश्व की अगर हम चर्चा करते हैं तो बहुत सारे देशों ने अलग अलग प्रकार के उपग्रह भेजे हैं, तो फिर भारत क्यों ऐसा प्रयास कर रहा है कि जिसके कारण हम ऐसा कुछ अलग सा महसूस करेंगे। तो मैं यहां आप सभी को ये जरूर बताना चाहता हूं कि आने वाले दिनों में विज्ञान एक ऐसा विषय है कि किसी एक देश की ऊपर हम निर्भर रह के विज्ञान का जो आगे का जो जिसको हम प्रवास कह सकते हैं या सफर कह सकते हैं, वो किसी एक देश के हाथ में होना असंभव है। क्योंकि जिस प्रकार का विज्ञान हम आगे आकर देखना चाहते हैं, जिस प्रकार के प्रौद्योगिकी को हम देखना चाहते हैं, उसमें हर एक देश को अपने पास अवेलेबल जिस प्रकार की टेक्नोलॉजी है, जिस प्रकार का विज्ञान है, वो सब लेके आना जरूरी है। और उसके साथ साथ एक मानवता को एक अच्छा सा समय से गुजरने के लिए प्रयास करना, ये हमारी सबकी जरूरत भी है और साथ ही साथ में उसकी आवश्यकता भी है। तो शायद मिशन आदित्य उसी की एक पहल जरूर हो सकती है। तो मिशन आदित्य से हम क्या हासिल करना चाहते हैं? जैसे आप सब लोग जानते हैं कि हम 21वीं सदी में चल रहे हैं और 21वीं सदी में लगभग हम सुबह से उठने के बाद से लेकर रात में जब तक हम सोने के लिए नहीं जाते, हम बहुत सारी अलग-अलग प्रौद्योगिकी के ऊपर निर्भर हैं। So that means right from the day, early morning to the evening, we are highly dependent on the technology that we use. And this case, holds true even in the case of all the investment that we as an humanity is trying to put into the space. And if you look at the 21st century, trillion dollar investment is already there in our space, ranging from 300 kilometers to about 1200 kilometers. That means huge amount of satellites are being placed in the space, and it is very essential that we really need to track on the radiation flow. The monitoring of the solar radiation becomes an essential, because when sun radiates and becomes a violent, the radiation that it comes to the height of the satellites where they have been parked and revolving around the earth in the various polar and the geosynchronous orbits, they are all under the threat of such enormous energy which is coming from the sun. So it becomes essential that all of us need to keep a track of how the behavior of sun is there, and how sun changes its behavior over a period of 11 to 22 years. As we know that sun has 22 years of magnetic cycle, or almost 11 years of what we call it as a sunspot cycle. And over the period of 11 years, sun goes in a high magnetic activities and comes down in the frequency of 11 years. So there are time in a days to come that huge amount of energies once the sun release, then that energy will have a very disastrous aspects associated with us. So it becomes essential that we monitor those radiations from the sun. And of course, when we say the radiations, it's not only that we really look only in a particular wavelength band, whether it is an X-ray or an ultraviolet, but it becomes essential that we really keep monitoring the sun throughout the electromagnetic spectrum, right from the high energy gamma rays to the lowest energy radio waves. So Aditya L1 is planned to be launched in a 21 or 22 at the location called as an Aditya Lagrangian point 1. That is what we call it as an Aditya L1. That L1 is a location which is about a 15 lakh kilometers as we proceed towards the sun. And these points have a very significant values, a significant point, as the gravitational force of the earth and the sun becomes a null. That is the point where the gravitational force of both the bodies become negligible or becomes a zero, where without much putting up an investment, we are in a positions to keep the satellite with minimum amount of investment and minimum amount of energy to be spent, and to keep it tracking all the times towards the sun. So that is whole purpose of keeping this Aditya at a location of L1, which is called the Lagrangian point 1. Will not focus on the rest of the Lagrangian points because that is not going to be important at this point. But as far as you all are concerned, this point is to be remembered for the significance of minimum investment and maximum output. Now, what are we going to achieve out of this particular mission Aditya is that we are trying to look for the reasons that the abnormal, or to some extent the irregular behavior of the sun. And we all know to large extent this abnormal behavior of the sun is the one of the reason is the coronal heating or coronal mass ejection. So we are really interested to understand what is the coronal mass ejection, or what is the coronal heating problem. It also becomes important to understand when the sun throws huge amount of energy into the interplanetary system, how the solar energy or solar wind behaves as it proceeds from the sun and goes into the various planetary system. That's why it becomes important to understand the intensity of those solar energy wind, the variation of radiations, the energy prospect, and altogether it becomes important to study this particular energy spectrum in a various energy band, especially the high energy band. Now, when I use such kind of terms, it might have been quite difficult for all of you to understand what do we mean by the coronal mass ejection, what do we mean by the solar wind, what do we mean by the coronal magnetophotography. So to understand that, I will in a shortly will let you know what the sun is and how we all should be concerned for the sun. As we all know, the sun is the only star in our solar system which is at the center and gives 99% of the energy that we receive on the planet Earth. And of course, when we try to look at the distance of the sun, then it is about 8 minutes away from the planet Earth. So it becomes so important for all of us that because sun is the most governing object in our solar system, and as long as we are in a position to understand its importance and the significance, we will be in a positions to track, monitor, and do the necessary corrections in the days to come. So to understand the sun is a huge and the biggest star as we know, which is very close to Earth of about 15 crore kilometers away from us, and gives the huge amount of radiation or huge amount of energy in terms of the Webers per meter square, that huge amount of energy which is being released, and that star is of the order of about a 7 lakh kilometer in radius. What is important in this particular slide is to understand the matter which is confined to the star like sun. The matter which is sitting on the sun is a highly been number one energetic. If you look at the temperature of the sun, that too on the surface, then it's about a 6000 Kelvin. So the matter which is sitting on the sun of the order of 6000 Kelvin is certainly not going to be easy to deal with and to easy to tackle with. Now, the another aspect of the sun is to understand when the matter is being thrown by the sun, then such matter will have a tremendously very high velocity, because when it has to escape from the sun, it will have a minimum velocity of 600 kilometers, because before that the matter cannot throw out of the sun's gravitational force or gravitational act, uh, what we say the gravity of the sun. So what becomes important to understand that if such kind of a mass is being going to be thrown in from the sun, this is certainly going to be very disastrous. Now, just to let you know that our sun is also uh, like all the other stars, but all the stars that we see are not stationary on its own way. That means every star rotates on their own axis, and especially when we look at the sun is also not a stationary, but it is continuously moving. And as we all know, sun is made up of the fourth state of matter, that is a plasma. And when we consider a plasma, which is nothing but the free electrons and protons, then at the temperature of 6000 Kelvin, this cannot rotate in a uniform velocity. And that's what we find that sun has a differential velocity if we look at the distribution from the polar region of the sun to the equatorial region. And that gives to understand that sun being a differential rotation star having a tremendously high velocity, at the same time it's a fully magnetized and the charged object, is going to give an enormous amount of issues to be generated out of it. Now, another important aspect of the sun is that sun is again not stationary in its orbit, it's continuously moving. And look at the velocity that the sun is revolving around the center of galaxy, then it is about 220 kilometers per second. That means the huge amount of velocity that it is having, but in spite of that, it takes about 100 million years to complete one rotation. That is to just give you the vastness of our universe in which we are living. Now, to let you know that ultimately what is the whole importance of this, presenting you all this information, is to give you the idea that sun is being a highly magnetized, highly active object which is in the close vicinity of the earth. It becomes important for all of us to keep a track of it. Otherwise, we are going to lead into the tremendous problem. Now, why do we are going to lead into the tremendous problem? Then it is important to understand that Sun, though it is an ordinary star, by looking at this small picture that you can see that Sun appears to be very ordinary star, looking at the size of the other stars in comparison to Sun, as well as the what we call it as an in the volumetric scale, then Sun is a very dwarf star that we all know. Uh, but in spite of that, what is more important here to understand about the sun is that sun has an atmosphere which is we all know from the outermost layer of an corona to the innermost atmospheric layer of the photosphere. Now, what is important in all these three layers is to understand that the radiation that we see that is coming from the sun, right? They are all actually represents the matter which is sitting in the photospheric region of the sun. So whenever we say that sun consists of enormous amount of metals in it, इसका मतलब ही यही मानते हैं कि जो सूरज के अंदर जितने भी हम धातुओं की बात करते हैं, जितने भी प्रकार के एटम्स की बात करते हैं, ये सभी एटम्स और मॉलिक्यूल्स की हम जो चर्चा होती है, वो सूरज के सतह पर मौजूद उसके फोटोस्फीयर के अंदर है। ये हमें कभी भी कंफ्यूज नहीं होना चाहिए कि ये जो मेटल्स हैं, ये सूरज के अंतर यानी आंतरिक भाग में है, ना कि ये उसके सिर्फ सतह के ऊपर है। यानी जितने भी हम प्रकार के मेटल्स देखते हैं, उसमें आयरन है, मैग्नीशियम है, सिलिकॉन है, जितने भी मेटल्स हम देखते हैं सूरज के ऊपर, ये सभी सूरज के सतह पर मौजूद इस प्रकार के मेटल्स उपलब्ध हैं। बट हमें ये भी याद रखना होगा कि 6000 डिग्री सेंटीग्रेड पे जिस प्रकार का मेटल्स हम सोचते हैं, उस प्रकार का मेटल धातु एक सॉलिड फॉर्म में ना होते हुए ये इसको हम एक आयोनिक स्टेज में होता है, ये हमें ध्यान में रखना होगा। और यहाँ पे कुछ प्रकार के चित्र आपके सामने दिखाए गए कि दिस इज व्हाट इज द सरफेस ऑफ द सन्स फोटोस्फीयर दैट वी कुड सी, एंड दिस लुक्स लाइक bubbling of water, and it is very much true that at the temperature above 6000 degree, what is going to happen is only the granulation process, and by which we understand is basically a huge amount of material which has been thrown into the atmosphere of the sun, or maybe the outside of the sun, will have this tremendous amount of energy which is of the order of 7 to 8000 or 7 to 6000 degree Kelvin. Now, the one layer just above the photosphere is called the chromosphere, where is a huge amount of emission lines are being observed. Those lines that we generally can see during the total solar eclipse, because that is the time where the photosphere is being obscured by the moon when we look at the solar eclipse. Now, these are the certain photographs that you could see, and these are all the real pictures. And these are through the coronagraph. When you take the sun's photograph, you see the sun is such enormously very high filamentary structure, and that we could see that these are the spicules which are available onto the sun. What is important to highlight, understand in this whole process is to understand the intensity, the amount of energy that is available onto the surface of the sun. And this is the last layer of the sun's atmosphere, which is known as a corona. Now, what is important and significance about this corona is something that is something which is very, very essential for the every individuals to understand. And in fact, this is more important for the scientific community to investigate. Now, as an average, understanding or a logical understanding about the sun's atmosphere is, as you go away from the sun's surface, there should be a drastic decrease in the temperature. But when you look at the temperature at the corona, which is enormously high, where the surface temperature is of the order of 6000 and the coronal temperature goes into the order of millions of Kelvin, this is something that we really need to understand. What I mean is, जिस सूरज के सतह का तापमान 6000 डिग्री टेम्परेचर है, जब वो कोरोनल रीजन तक आता है, उसका तापमान लगभग 10 लाख डिग्री सेंटीग्रेड से ऊपर चला जाता है। यानी ऐसी क्या प्रोसेस है, ऐसा क्या हो जाता है कि जिसकी वजह से जो सूरज से निकलने वाली रोशनी है, पदार्थ है, वो इतना बड़ा टेम्परेचर या उतना बड़ा तापमान लेके निकलता है। तो इसका मुख्य कारण हम यही कहेंगे कि जिसको अभी तक पूरी तरीके से हमें इसका कारण नहीं समझ में आया है, लेकिन ये कारण हम समझने की पूरी कोशिश कर रहे हैं, और शायद मिशन आदित्य भी हमको इसी के बारे में जानकारी देने में मदद करेगा। अभी अगर हम सूरज के अंतर्गत रचना की बात करते हैं, तो हेलियो सेस्मोलॉजी के माध्यम से हमने सूरज के अंदर का जो एक स्वरूप है उसको समझने की कोशिश की है, और उससे हमें पता चलता है कि सूरज का जो आंतरिक भाग है वो तीन हिस्सों में बटा हुआ है, जिसमें हम एक को कोर कहते हैं, दूसरों को रेडिएटिव जोन, और सबसे ऊपर वाला जो फोटोस्फीयर के नीचे है जिसको हम कन्वेक्टिव जोन कहते हैं। तो एक प्रकार से अगर हम इन तीनों चीजों को देखने की कोशिश करेंगे तो हमें पता चलता है कि लगभग 25% हिस्सा जो हमारे सूरज का है वो प्योर हाइड्रोजन से भरा हुआ है। और वहां पर अगर हम देखते हैं तो वहां का टेम्परेचर जो है सतह के टेम्परेचर से कई गुना ज्यादा दिखाई देता है, और उसका कारण भी स्वाभाविक है। जिस प्रकार से हम आइडियल गैस इक्वेशंस को देखते हैं, पीवी इज इक्वल टू आर टी, यानी जितना ज्यादा प्रेशर होगा उतना ज्यादा टेम्परेचर होगा। यानी अगर हम उसके केंद्र की बात करते हैं तो इतना ज्यादा प्रेशर उसके ऊपर होने के कारण हम उसके अंदर का जो टेम्परेचर है वो नियरली 13 से 15 लाख डिग्री केल्विन बनता है। और उसी के कारण वहां पर न्यूक्लियर फ्यूजन रिएक्शंस होते हुए दिखाई देते हैं। और यही जो एनर्जी है जो बनती है वो ज्यादातर हमें देखने को मिलेगा कि ये प्रोटॉन प्रोटॉन चेन से बनते हुए नजर आती हैं। और अगर हम कितनी इस प्रकार की रिएक्शंस हमें देखने को मिलती है तो सिर्फ एक सेकेंड के अंदर 10 का 37वां घात यानी 10 raised to 37 such reactions happens within a 1 second. That gives to understand the huge amount of energy which is being released by the sun at the core of the center. However, what is important to understand is that the energy released at the core of the sun not necessarily will reach onto the surface in a very instantly, but it takes a huge amount of time to understand the the whole process or the internal structure of the sun. Now, when we look at the physics of this, we all know there is a three mechanisms through which the energy transportation is possible in physics. When it is happens in the solid, we know it is a conduction. When it happens in the liquid, it is a convection. And when it happens in the gas or the others, the form of matter in plasma, then it is a radiative zone or the radiation through which the energy transportation happens. So the energy which is being produced at the core get transmitted into the convective zone through the radiative zone, that is with the form of radiation. Now the outermost layer of the internal structure of the sun gives rise to understand the convective zone, in which the huge amount of energy which has been released from the core reaches to the almost surface of the sun, that is at photosphere. But the energy that is coming from the bottom or from the below the photosphere is through the convective mechanism. And that reminds me to again tell you that when you looked at the photosphere of the sun, there you saw the kind of an bubbling process, or what we call it as a granulation. This is nothing but because of the convection process which happens below the photosphere. Now, by this particular time, if you can imagine, as a student of science or as a student of physics, there are few things which are very absolutely clear. A matter which is of the temperature of the matter which is at the temperature of the order of 6000 Kelvin cannot remain in any solid, liquid, or gas. Then it has to be in the fourth state of matter. And as we all know from the physics, that any matter which is in the form of an such a plasma, then it has to be fully charged. And that is what we come to know from the Coulomb's law, that wherever there is a charge, there is an electric field has to be associated. And that gives rise to understand through the Ampere's law that there has to be current generated out of it. And there is a third and important aspect of this is to understand that sun is rotating on its axis, but it has a differential rotation. And because of the differential rotation, these electric fields or the electricity which is being generated on the earth, on the sun, is continuously moving through this changing electric field through the differential rotation. And that gives rise to the understanding of the fourth law in the physics, that is the Faraday's law. That is, whenever there is a change in the electric field, the change in the magnetic field is bound to be occur. And that gives rise to understand that sun is a star which is full of magnetic activities. And when we look at the magnetic activities, there is a possibility of having solar flares, sunspots, and the huge amount of material which is produced on the sun. Now ultimately that generated material cannot stay onto the surface of the sun, because when it releases from the sun, then it will have a huge amount of energy as well as the velocity, and that matter will be thrown into this interplanetary space, and that's what we come to know through the solar wind. Now ultimately the point of reference to mention all of you कि इतना सारा अगर अगर हम चुंबकीय पदार्थों से बने हुए इस मटेरियल को अगर हम देखते हैं, तो हमारी जब ये पूरी प्लानिटरी सिस्टम में आएगा तो वो किसी भी शांत स्वरूप से नहीं आएगा, शांत स्वभाव से नहीं आएगा, बल्कि इसमें जितना भी वायलेंट नेचर जिसको हम कह सकते हैं कि एक रौद्र रूप धारण करके ये निकलने वाला जो पदार्थ है वो हमारे पूरे सौर मंडल में आता है, और ये जब आता है तो बहुत सारी चीजें उसके साथ एसोसिएट होती हैं। और इसी से अगर हम देखेंगे तो इसी का एक उदाहरण है कि हमारे सूरज के ऊपर बहुत बड़े सौर दाग हमें दिखाई देते हैं, और ये सौर दाग हमें इसके 11 ईयर का यानी 11 साल की जो साइकिल जिसको हम सनस्पॉट साइकिल कहते हैं उसके बारे में हमें ये बताने में मदद करता है। और हमें इससे पता चलता है कि जितने भी प्रकार से ज्यादा सनस्पॉट सूरज के ऊपर निर्माण होंगे उतने ज्यादा डिफिकल्टी और उतने ज्यादा डरावनी चीजें हमारे लिए हो सकती है। इसलिए हमें ये हमेशा ध्यान रखना चाहिए कि सनस्पॉट इज नॉट अ गुड इंडिकेटर of anything that we talk in terms of the sun, because as many sunspots that we see, that gives rise to understand the huge amount of problems are going to be occurred through the solar winds as well as the huge amount of energy which is released by such kind of an phenomena that we see. Now one of the aspect of this solar energy that we could see, that when this kind of a solar wind is being thrown into the interplanetary mission or interplanetary space, अर्थ इज एट द थर्ड प्लेस। पृथ्वी हमारे तीसरे स्थान पर होने के कारण और हमारी पृथ्वी पे वातावरण होने के कारण, जिसमें शायद आप सब लोग जानते ही होंगे कि हम ट्रोपोस्फियर, स्ट्रेटोस्फियर, मेसोस्फियर और सबसे ऊपर आइनोस्फियर की बात करते हैं, जिस प्रकार के हमारा वातावरण बना हुआ है पृथ्वी के ऊपर। लेकिन इससे भी कहीं ऊपर जाके अगर हम देखेंगे, जब लगभग 36 लाख किलोमीटर पे, तो हमारे धरती को एक बहुत ही स्पेशल प्रकार की एक लेयर हमें प्रोटेक्ट करती है जिसको हम मैग्नेटोस्फीयर कहते हैं। और उस मैग्नेटोस्फीयर के कारण ये जितने भी प्रकार का थ्रेट्स हमें सूरज की तरफ से आता है उसको कहीं ना कहीं प्रोटेक्ट करने के लिए मदद करता है, क्योंकि वो जो मैग्नेटोस्फीयर है वो आने वाले इस प्रकार की सबसे ज्यादा ऊर्जावान एनर्जी रखने वाला जो इसके तूफान है, सौर तूफान है, उसको रोकने में सक्षम होता है। लेकिन हम ये सब जानते हैं कि हमारे पास जोग्राफिकल नॉर्थ और साउथ है, उसी प्रकार से हमारे पास मैग्नेटिक नॉर्थ और साउथ है। अगर हम पूरी धरती को एक मैग्नेट के रूप में देखते हैं, यानी दो ऐसे बिंदु होते हैं जहां पर इस प्रकार का मटेरियल धरती की तरफ आने में सक्षम हो सकता है, और वो है मैग्नेटिक पोलर रीजन ऑफ द अर्थ एटमॉस्फेयर। और यहाँ पे अगर हम देखेंगे, और ये दोनों रीजन्स हैं, वो या तो हम अगर हम पृथ्वी के उत्तरी अक्षांश की तरफ देखेंगे यानी 70-60 से ऊपर अक्षांश की तरफ देखेंगे, या 60 और 70 अक्षांश दक्षिण की तरफ देखेंगे, तो हमें इस प्रकार की फिनोमेना देखने को मिलती हैं, इस प्रकार के ऐसे दृश्य देखने को मिलते हैं जिसको हम अरोरास के नाम से जानते हैं। So I think though it looks very fascinating to all of us, where we really get fascinated to take such kind of photographs, but one of the important aspect to remember is that as much intensified auroras that you are going to see, that means you need to understand that much of danger is there in a sun to come. So I'm just giving you a small, this kind of simulations or animations to demonstrate how these sunspots are being generated. And I'm just concluding. I know the time is very short. So this is how, if we consider sun as a magnet, moving the magnetic field lines from north to south, and because of the differential rotation, sun continues to move, and that gives rise to break off these magnetic flux lines. And when they break down, they fall back onto the surface of the sun, and wherever they fall onto the surface of the sun, we see those kind of dark spots. Please remember, dark spots are nowhere concerned with having any hole on the surface of the sun, but these are all the regions which are comparatively low temperature regions onto the surface of the sun. However, the temperature at the sunspot region is also of the order of 4000 to 4500 Kelvin, but the surrounding temperature is of the order of 5800 to 6000 Kelvin. And because of the temperature difference, we see the sunspots are black in nature. And this is the another simulation that you have seen, or the animation that you have seen, that when such kind of an solar winds are being thrown into the planetary system, there are only two locations where these kind of solar energies or the material or the highly energized material is in a positions to reach onto the surface. Well, not exactly on the surface, but on the upper atmosphere of the Earth's no atmosphere, and that is where we see such kind of an auroras. And this is the three-dimensional picture visualized from very far away location into the planetary system, and that we see that these kind of auroras are being formed in the northern region. Those are called the aurora australis, and when it is in the northern hemisphere, southern hemisphere, sorry, it is in the northern hemisphere, it's called aurora australis and aurora borealis. So this is how that we could understand that, looking at this importance of this energy which is being released by the sun, what is important in the point of view of a mission Aditya, that we are seriously looking for understanding the abnormal behavior of the sun. But ultimately abnormal behavior can only be investigated, only can be explored when we look at the material which is coming from the sun in the form of solar radiation, in the form of highly energized particles. And that's the reason that we must understand this mission Aditya, having a seven different payloads which are going to be placed on this mission Aditya, are going to investigate and are going to lead to the understanding of all the different nature of this sun's material in the form of what we know as a plasma, is in the form of various highly energetic material. And these different number of technology demonstrations, and these are all the different kind of an instruments which are placed onto the mission Aditya. What is to be understood in the whole process on the occasion of National Technology Day is that all the technology that we are looking at, it's everything right from its transistors to the ICs, everything that is being developed well within our own country. And that becomes and more important to highlight this point on the occasion of National Technology Day, that the three payloads that you are seeing here, that is a visible emission line coronagraph, solar ultraviolet imaging telescope, Aditya solar wind particle experiment. Basically, these are all the indigenous payloads or the instruments getting developed at various institutions like Indian Institute of Astrophysics, Bangalore, Inter-University Center for Astronomy Astrophysics, Pune, Physical Research Laboratory, Ahmedabad. And these instruments are going to measure the nature of the plasma or nature of the energy particle which are being thrown from the sun, and understanding those in a various wavelength band is the something that we really need to understand. Because even today, after the development of science and technology in the last 100 years time, we have not yet really understood the basic reason of coronal mass ejection, which gives rise to the enormously high temperature in the coronal region of the sun's atmosphere, which is in the order of few lakhs degree Kelvin. And this is something that we need to understand. And this is the I would say multi-purpose mission that we look forward. And with these instruments like a plasma analyzer package, solar low energy X-ray spectrograph, high energy orbiting X-ray spectrograph, or a magnetometer, is something that we are looking forward, that huge amount of this payloads or an instruments which are getting designed within the India is trying to look at and find out the nature of those elements which are coming from the through the solar winds, in the form of their distribution, in the form of their nature, how are they getting generated at the region of the convective zone, or at the region of the radiative zone, and how the behavior of such thing is becomes important. Now ultimately, what is important to highlight and understand in the whole of this mission Aditya is, ultimately this is the reason, or this is something which is going to help for the entire humanity across the globe, because we all need to be together. We all need to be part of such mission and try to investigate, understand the reasons behind the various aspect of the sun's nature, so that the investment that is been in the space in terms of $1 trillion economy which is sitting in the space need to be carefully watched, because if we are not going to take care of the nature of the sun, all the investment which is there in the space is going to be at the sake or at the mercy of the sun's behavior. And if we are not going to keep it watch on it, then all this investment is going to be damaged without taking much time, because the material that we see in the satellites have a certain energy to be able to tackle, but beyond that it cannot. And I'm just ending my talk by showing you the real pictures of the sun taken in the ultraviolet x-rays, and these are all the real picture. These are not the animations, these are not the simulations. And this is now because of the technology, we really need not have to wait till the total solar eclipse to be observed to understand the nature of the plasma in the coronal region and how the coronal mass is being ejected and reach to the various part of the solar system. And all this is the real pictures that gives rise to understand that how the sun is going to be in the nature, or how it is going to be in its life. This is the last slide which tells you that if we look at the sun today, then it's at the middle of its life. Half of the life of the sun is over, but half of the life is still there, but does not mean that the humans will be in a positions to survive for such long, because maybe within the next 1 billion years or so, we will be having a huge amount of problems because of the number one, there are few human created problems, man-made created problems, as we all know the reasons of the global warming, and then we all talk about the climate change. So otherwise also, if we look at this, without the human intervention also, the sun is gradually going into the different phase of its evolution, and the sun is going to be end up its life in through the planetary nebula system and will end up its with the dwarf star.